So this is the second of the integrating logs questions from your notes. Let's work this one through using the technique I showed you. So we want to integrate this log between 4 and 0. So essentially we want to find the area, or this area here under the curve. So it's this stuff here that we're after. Now the only problem is if we have to do this problem by hand, we can't integrate the log. So the technique I showed you is that what we do is we find the inverse of this log here, which, let's write it out. So y equals log e x plus 5. Inverse, we swap x and y. E to the x, take 5 equals y. Okay, so there's our inverse. Let's plot the graph of the inverse. Now remember that the graph of the inverse is the original reflected along the line y equals x. So let's plot the line y equals x to give us an idea of what it will look like. So it'll go there. Oh, this is really thick. So that's basically the line there. Now notice that the Cartesian plane is not 1 to 1, so that is 1 there is not the same distance as 1 there. So what we're going to get is the plot of the inverse is going to look a little skewed, but that's all right. So let's get our coordinates that we're going to use. So this one here is when x is 0, y is log e5, and when x is 4, y is log e9. Okay, so when they swap, what will happen is this coordinate point will swap to become the swap x and y. So this is roughly 0, and log e5 looks to be 1.2, 1.4, roughly 1.6. And this one here looks to be 4, log e9 looks to be roughly 2.2. So let's plot those points. So 2.2 is here and 4 is off the Cartesian plane, so roughly there. Oh no, not there. 2.2, somewhere up here. And the other one was 1.6, so 1.2, 1.4, 1.6 and 0. So it's going to be an exponential curve linking those two values up. So best effort here. There it is. All right, so the strategy we're going to use is I'm going to get this area here. All right, this is the stuff that I'm after. Now, why am I after that? Well, what that will be is exactly the same as dotted line, please. Ah, come on. It's going to be exactly the same as this area here. All right, now when we get this area here, what we can do is actually draw a box to form a rectangle, subtract this area from the overall rectangle, and what we'll do is it'll actually leave us with the area under the curve. But we're going to do that in reverse. Okay, so what we're going to do is find this area here, draw a box, which will be draw my box now. Be this one here. And what I'm going to do is find the area of this rectangle. It doesn't look that rectangular, but it is. I'm going to find the whole area, remove this part here, the area that I just found out, and what it will give us is this part here, which is actually the same as, choose a different colour, which will be the same as the area that I'm trying to find. And what it will allow me to do is to find the area under a log graph without having to integrate a log. Okay, and that's really what this technique is all about. Right, so let's go and find this green area here. So area green is equal to the integration between this value here and this value here, which is, the top one is log E9, the bottom one is log E5. The function is e to the x take 5 dx. All right, let's do it. So that one's easy to anti-diff. E to the x take 5x log E9 log E5. Okay, so let's bang them in. E log E9, take away 5 log E9, take away E log E5, take away 5 log E5. Okay, now that is just, that should be a 9. That should be, so 9 take away 5 log E9. Let's keep the brackets in there. Take away 5, take away 5 log E5. Okay, so this is going to be 9 subtract 5, which is 4. Take away 5 log E9 plus 5 log E5. Now we can combine this or we can leave it like that. I reckon it might be easier if we just combine it. So I'm going to take 5 out as a factor, log E9, take away log E5. And when we subtract common base logs, we divide it. So 4 take away 5 log E9 on 5 units squared. Okay, so the area of the green part is this area here, whatever that is. Right, now what I'm going to do is find the area of the rectangle. So I'll do that over here. Area rectangle is the length by the width. The length, we'll go this dimension here, is log E9. The height, how high does it go? 4. So it's going to be 4 times log E9, or just 4 log E9 is the total area. Right, so that's the rectangle. Now my total area equals the rectangle, take away that small area, that green one. So that's going to be 4 log E9, take away 4 plus 5 log E9 on 5. Right, the question is, so that's in units squared. The question is that the same as what the calculator is going to give us? I doubt it. The calculator will do all of these moves, these simplify moves on this, and try to present it in as compact a way as possible. So like, I'm pretty sure what the calculator will do with this one here is write that as 4 log E3 squared, and it's going to grab that 2 and write it there. So I'll just finish this off. It'll go 8 log E3, take away 4 plus 5 log E9 on 5. What it would have done, it will take that 9 and convert it to a 3 and probably attempt to combine that. Anyway, there's all sorts of moves you can make. Let's just fundamentally work out whether we've got this right or not. Okay, so we'll integrate the original log, which we can do on the calculator. Calculator will do it, no worries. So that's going to be 4 and 0 ln x plus 5. And let's work out what ours is. So I'll type this one in. So 4 ln 9, take away 4 plus 5 ln 9 on 5. All right, so if this comes out as 7.27, we know we got it right. We've just got it in a form that may or may not be what the calculator has. So let's just check it out. Hey, we got it right. Okay, so that is the correct area. Now the question is, what did the calculator come up with? So we're going to standard. Yeah, I reckon, so what they do is they'll convert this 9 into base, that'll be log E3, and then they'll have they'll have 10 lots of this and 8 lots of this, which is the 18 log E3, and then they'll have this 5 log E5 here. So yeah, again, whether that's better than my answer, I don't know, but all I know is my answer is correct.